Hi there, folks. Today we're going to start graphing linear equations, and we've already kind of gotten a preview of this. And really what we're going to do today is very similar to some of the lines we started to see the other day. The big difference is this. The first thing we're going to have to do is make sure the equation is solved for y. The ones that we've been given before today were already y equals. They were already solved for y. So we're just going to have to rearrange the equation a bit first. And then we're going to make a table of values like we did before. But the difference was before I gave you domain values. I told you what to plug in. Now we just kind of have to decide on our own what we're going to plug in. All right. And the key there is going to be picking values that we think are easy to plug in. All right. They can be any values we want. We just want to pick the ones that seem to be the easiest. All right. And then once we've done that, then we're going to make our graph. We're going to plot our points. We're going to look for patterns. We're going to draw our line. Okay? For example, if I look at something like this guy, the first thing I want to do is I want to solve this for y. I want to get y by itself, all right? So right now, y is not by itself. It's got that negative 2x with it. So what I have to do is I have to get rid of all the stuff that's not y, all right? So if I want y by itself, I got to get rid of the other things, okay? So to get rid of a minus 2x, I have to add 2x. And remember, whatever I do to one side, I have to do to the other side. And so when we do this, this says y equals, from here, I've got a minus 3 and a plus 2x. I cannot add those together because one is an x and one is just a number, all right? So I have to leave them separated. The preference here is to always write the x first, all right? So I'm going to write the positive 2x and then the minus 3, all right? Now I have this thing solved for y. Now I can make an xy chart, okay? And when you make your XY chart, once again, we want to pick the values that we think are the easiest to plug in, but we also typically want to get a variety of values, all right? And my preference, here's the values I always start with, unless it looks like they won't be easy to plug in, all right? So kind of look at the equation and ask yourself, when I'm looking at this guy, I want to multiply it. So if I'm plugging in for x, I multiply by 2 and subtract 3. So are there numbers that are easier to multiply by 2 than others? Not really. All right, they're all pretty easy. So here's the typical ones that I start with. I always start with -2, -1, 0, 1, and 2. And the reason I do that is because those numbers are small, which makes them easier to deal with. But it also gives me a big variety here, okay? I have some positives and some negatives, and I have 0 in there, which is kind of an oddball number, all right? So I get this nice variety of numbers, but they're also small numbers that make them easy to plug in, okay? So take it off to the side, plug it in, write it out if you need to. We're going to try to do this with some mental math. You ready? So I'm going to plug the -2 in for x right here. All right, the other day I showed it. Now we're going to try some mental math. So 2 times -2 is a -4. -4 minus 3 is a -7. Okay, and if you're looking at that going, I can't do that, Mr. Jansen, that's okay. Take it off to the side. Use your parentheses, plug in that -2, and now take it step by step, okay? Take it one step at a time, all right? Or use your calculator a little bit. And the thing about the calculator, once again, you should always plug things in using parentheses, and then when you plug it into your calculator, use those same parentheses, and you will always get the right answer, okay? The mistakes the student make plugging things into the calculator is they don't have parentheses when they need parentheses, all right? So now let's plug the -1 in for x. Ready? 2 times -1 is a -2. -2 minus 3 is a -5. Now we're going to plug the 0 in. 2 times 0 is a 0. 0 minus 3 is a -3. Now I plug the 1 in. 2 times 1 is a 2. 2 minus 3 is a -1. Now I plug the 2 in. 2 times 2 is a 4. 4 minus 3 is a 1. And so now I have my XY chart. I can start to plot these things. So let's see, -2, -7. It's right here. -1, -5 is right here. 0, -3, 1, -1, 2, 1. And so as I look at this, I still want to look for and identify if there's any patterns happening. And yeah, as you look from one point to the next, there's an obvious pattern. To get from one point to the next, I go up 2 and then over 1. And then to get to the next point, it's up 2 over 1, up 2 over 1. To get to the next point, it's up 2 over 1. I can keep that pattern going up 2 over 1. Up 2 over 1, up 2 over 1. And by using that pattern to get extra points here, well, one, it gives me a really it gives me a much easier time drawing a line that's straight, especially if I'm not using a straight edge. The more points I plot, the easier it makes this thing. But it also should lead me to realize, do I necessarily need as many points as I graphed? Okay, if I know that this thing is kind of going to be a line, once I have the pattern, think about how many points I really need to get that pattern and to be able to plot those points using the pattern. Okay, so start to think about that. If I look at the next one, again, I have to solve it for y first, so I got to get y by itself. To get y by itself, I have to get rid of that plus 3x. To get rid of a plus 3x, I have to subtract 3x. Whatever I do to one side, I have to do to the other side. And so now over here, I'm just left with y. Over here, once again, I can't do that subtraction. -2 and -3x, because one's an x and one's just a number, I can't subtract them. I have to leave them as a -3x and a -2. And the proper way to do it, quote unquote on proper, is I should write the x first. So I'm going to write down the -3x first and then the -2. And if you show those steps that I've been showing, that -3x on each side, it should be fairly easy to go from this to this, all right? Because, when I look at those things, it's really just writing the same things down. I just have to choose what order I write them down in, okay? If you don't show that step that I've been showing, you're probably going to lose something as you try to do that in your head, okay? So now go into an XY chart here. And so I'm going to use the same old values, -2, -1, 0, 1, and 2. And again, the reason for that is because that's kind of what I just typically use. And when I look at this equation, I mean, are there some values that are easier to multiply by 3 than others? I mean, not really. The smaller, the better, right? So now let's plug it in. Let's see if we can do the mental math. Ready? I'm plugging it in right here for x. So I plug the -2 in there for x. So now I have -3 times -2 is a +6. +6 minus 2 is a +4. Now I'm going to plug the -1 in. -3 times -1 is a +3. +3 minus 2 is a +1. Now I'm going to plug the 0 in. -3 times 0 is a 0. 0 minus 2 is a -2. If I plug the 1 in, -3 times 1 is a -3. -3 minus 2 is a -5. Now I plug the 2 in. -3 times 2 is a -6. -6 minus 2 is a -8. And once again, let's watch this for a second. I'm going to plot just the first couple points. Ready? I'm going to plot -2, 4 is right here. And then I'm going to plot -1, 1. And then how about I'll plot 0, -2. All right, and I'll stop there. I'm not going to plot the next two just yet. Let's look at the graph. Let's ignore those other 2 points for a second. Just looking at the graph, let's think about the pattern. Do I see a pattern to get from one point to the next? And the answer is yes. To get from one point to the next, I go down 3 units and then over 1 unit. And then again, I go down 3 units and over 1 unit. So if I keep the pattern going, down 3 units and over 1 unit, down 3 units and over 1 unit, do you see that I just plotted the 2 points that I found in my XY chart anyway? But the idea here is start to think about, did I need all those points in my XY chart? Or could I have stopped after just doing those first 3 points? Or maybe I didn't even need 3. Could I have stopped after doing 2 points? Did I only need 1 point? Okay, that's the kind of thing we want to start thinking about, all right, is how many points do I really need? And if I continue the pattern going the other way, watch, it's up 3, back 1, up 3, back 1, right here, okay? So again, how many points do I really need to identify that pattern? Something to start thinking about, okay? And also make sure you're putting those arrows on each end. The idea behind the arrows is that the pattern keeps going even though my graph kind of runs out of space. All right. So keep that in mind. The only reason I've only plotted those points is just because that's all I could fit on this graph. Okay. There are more points that go forever and ever. All right. That's why we put the arrows on. And now how about this guy? Again, I want to get the y by itself. And now there's two things happening to y. Y is being multiplied by 2, and I'm adding an x. So when I solve, remember, I have to go backwards through order of operations and undo the operations that I go as I go. So I have to undo the addition and subtraction first, then undo the multiplication division. So to undo adding an x, I have to get rid of that x. I'm going to subtract x from each side. Okay? So that gives me a 2y equals. Over here, I cannot subtract those things because one's an x and one's a number. They don't play nice together, all right? So I have to leave them as a negative x and a positive 4, but determine the order. I'm going to write the x first. So I'm going to write the negative x down first, and then it's a positive 4, so I have to write a plus 4. And we have to be very literal about the sign there, because if I don't put that plus sign there, it's going to look like x times 4, okay? That's the reason I need it. But now to undo multiplying by 2, I have to divide by 2. And so here I get y equals. Keep in mind that this is a 1 right here. It's a negative 1x. Well, I have to use my distributive property here. I can't leave it like that. I mean, I could, but it's weird to leave it like that, all right? We want to get in the habit of simplifying using our distributive property. So watch this. Ready? Negative 1 divided by 2. Let me write it off to the side. Negative 1 divided by 2. Well, that's the answer. I literally leave it like that. Remember, a division sign and a fraction sign are the same thing. Negative 1/2. X. And now the next one, 4 divided by 2. I can take that one off to the side too if you need me to. 4 divided by 2 is a 2, so plus 2. And see, now we're in business. Now I can start to plug this thing in. So here's my XY chart. And see, as I'm about to do my XY chart, I'm thinking about those typical values, but look at what's happening to X. It's times a negative 1/2, and then plus 2. And remember, fraction bars are just division signs. So times 1/2 really means divided by 2. So now start to think about this. Are there numbers that are easier to divide by 2 than others? And the answer is yes. Maybe instead of those typical values, maybe I'll use things like negative 4. Negative 2, 0, 2, 4. I'll use values that are divisible by 2 because that's the first thing I have to do when I plug it in, okay? So now, again, times a negative 1/2, that's the same thing as divided by negative 2. So right here, when I plug these guys in, mental math, here we go. Negative 4 divided by negative 2 is a positive 2, plus 2 is a positive 4. Negative 2 divided by negative 2 is a positive 1, plus 2 is a 3. 0 divided by negative 2 is a 0, plus 2 is a 2. 2 divided by negative 2 is a negative 1. Negative 1 plus 2 is a positive 1. 4 divided by negative 2 is a negative 2. Negative 2 plus 2 is a 0. And now I can plot these. And once again, as I plot these, maybe I'll plot the first couple. Let's see, negative 4. 4 is right here. Negative 2, 3 is right here. And as you're watching me plot these, think about, do I already know what the pattern is? Could I use the pattern to keep graphing this? And think about how many points I really need. 0, 2 is right here, 2, 1. And see, at this point, I'm literally just graphing the points that follow the pattern. The pattern is down 1 over 2, down 1 over 2. But again, start thinking about how many points do I need before I can use the pattern, okay? That's going to be a big thing that we do in the next lesson, okay? All right, let's do a word problem. Everybody loves to read a little bit. Ready? So Forrest goes for a run as his time and distance are modeled by the function d equals 6t, where d is the distance in miles and t is the time in hours. graph the function, and identify the domain and range. So for our purposes, we're not going to be crazy about domain and range here. What I really want you to do is think about the domain and range. Think about what I'm actually allowed to plug into this equation. Okay, so as we do this thing, when I do this, instead of an XY chart this time, see, instead of Y, I have a D, and instead of X, I have a T, so it's going to be a TD chart this time. But now think about it for a second. T is the time. Normally, I start with -1, or -2, -1, 0, 1, and 2, all right? Could I have a time of -2? Well, no, time can't be negative. That's crazy talk, Mr. Jansen. Could time be a -1? No. But how about this? Could time be 0? What would it mean if he ran for 0 hours? It means he didn't feel like going for a run that day, or maybe it was raining that day. I'm not going to run in the rain. So the first value I'm allowed to use is 0. And that's what we're talking about when we say identify the domain and range, think about the domain and range. The domain is what we plug in. Well, in this case, I can't plug in negatives. I have to start with 0. And then I could plug in things like 1 or 2 or 3, okay? And so now here's my function. It was d equals 6t. Let me rewrite it. So use that mental math. Let's plug the 0 in. 6 times 0 is a 0. 6 times 1 is a 6. 6 times 2 is a 12. 6 times 3 is an 18. And so now I can plot this thing. I'm going to do my time down here. This is where I'm going to put the time. That's going to be like my x. And then the distance will go up here. That'll be like my y. So now I have the ordered pairs. I've got 0, 0. I've got 1, 6. I've got 2, 12. And again, as I'm plotting those, think about how many I really needed before I could use the pattern to get the next one. And really, 318 is not even going to fit on my graph. It's going to look like this. And I said those arrows were important, so I just put an arrow on one end. Why don't I put an arrow on the other end? Will the pattern continue in this direction? And the answer is no, because we already decided we can't have negative time, and I also can't have negative distance. So when we talk about domain and range, I'm just asking you to think about it here. Understand why we only have an arrow on one end of this thing, okay? Yeah, he could keep running for hours and hours and keep increasing his distance, but he can't go in the negative direction, okay? The last thing we're going to look at here is vertical and horizontal lines. These are kind of special. They're in their own category. Vertical lines are in the form x equals some number, okay? It says c, where c is a constant value. Constant value just means a number, all right? So x equals a number, all right? Horizontal lines are in the format y equals a number. And the reason for that we'll see as we start to think about the ordered pairs, okay? We start to think about the ordered pairs, all right? If the x value doesn't change, if the x value stays the same, if the x value is always the same number, we get ordered pairs that are directly above one another, giving us a vertical line, okay? If the y value stays the same, if the y value doesn't change, all right, I get ordered pairs that are next to each other, all right, because the y value is staying the same, and that creates a horizontal line. So here's what that looks like. Ready? So y equals 2. So y equals is a horizontal line. So think about where y is, where 2 is on your y-axis. It would be right here. And so now I just draw a horizontal line. And yeah, we have to remember that. We just have to remember that y equals is a horizontal line. But again, here's why. Let me identify the ordered pairs on here. Here's a bunch of ordered pairs on this line. Okay, see I'm highlighting them a little bit. So like I have the ordered pair -3, 2. And I also have the ordered pair -2, 2. And I also have the ordered pair -1, 2. And I also have the ordered pair 0, 2. And I also have the ordered pair 1, 2. And I also have the ordered pair 2, 2, and 3, 2, and 4, 2, and 5, 2, and 6, 2, and something 2, and 1,000,000, 2. But you notice the y value for all of those ordered pairs, the y value is 2. When the y value stays the same, it means this line doesn't go up and down at all. It stays at the same height. It stays at the same y value. That's why it's a horizontal line. And students mix these up all the time. We know the y-axis is the vertical axis, but y equals a number is a horizontal line. And here's why. It's because the y is the thing not changing, okay? Vertical lines are kind of the same way. Ready? X equals a -4, so find the x value of -4 on your x-axis is right here. And now we just draw a vertical line. And again, that's confusing for students because x is the horizontal axis, right? But x equals a number is a vertical line. Well, here's why. Think about the ordered pairs on this thing. Here's some ordered pairs. Ready? Start identifying some of those ordered pairs. I've got things like -4, 2. And I've got -4, 1. And I've got -4, 0. And I've got -4, -1. And -4, -2, and -4, -3, and -4, -1 million. Notice the x value is always -4 for every ordered pair. When the x value doesn't change, it doesn't move left and right, which means the line can only go up and down. Okay, so keep that in mind. So graphing lines, we want to start identifying that pattern, all right? But we use an XY chart to do that, okay? To do your XY chart, you have to solve for y first, then pick values to plug in, and always pick values that are easy to plug in. Plot those points, look for the pattern, graph your line. And then our special case is y equals a number is a horizontal line, x equals a number is a vertical line.